So tonight you're going to find out what this is, and I'll tell you the 3 reasons why future robots will be designed using this model. And the third part we'll talk about is why it's useful for everyone else, even if you never ever plan to design a robot. So these are great times for the spatial geometry of Buckminster-Fuller. Thank you. That's Buckminster-Fullerian on the left there, and a nanotube. There's a whole branch of organic chemistry that's about these now. But the most important thing that Fuller studied was actually invented by one of his students, an Oregon native, Kenneth Nelson. And that was back in 1948. He studied under Fuller for a couple summers. He called them floating compression models. Bucky picked a much sexier name. He called them tensegrity structures, which is just a mashup of tensional integrity. So turn to your neighbor and say tensegrity now. Thank you, that's the hardest part about it. This is the Corypa Bridge in Brisbane, Australia. Beautiful bridge, you should go down there and look at it. And the fundamental definition of these structures, the tension holds the parts apart. Now that sounds really simple, but this is the second way civilization has ever learned to create structure. And the loads are actually borne by the tension, not by the compression. This is very different from the way we learned how to build things growing up. We stack things on top of each other. We jam Tinker toys together in Legos, and then we start building bigger toys, we weld and rivet them together. So, the first fact about these, they're remarkably material efficient. They're used in all sorts of aerospace applications, things in orbit. Nature is also fiendish for efficiency. It's used in all sorts of living structure, including our musculoskeletal structure. Second part about them, they're energy efficient. If you put an egg in the center of this and let it drop, the whole structure would support the egg when it hit the ground, not just the part between the egg and the ground. That's remarkable. This is called the sweet spot for the tensegrity when it's balanced. So it's very fluid when it's in its sweet spot there, and then it starts to get rigid after that. So if you grab your ear and gently pull on it, you'll see what I'm talking about. It's very fluid, but then if you start to pull it just a little bit more, it starts to get rigid at that point. So that's non-linear. Also, if you squeeze it, you'll find the same thing that happens there. Robots are different than that. The stresses and strains actually work in a linear fashion with robots, and it actually takes more effort for them to move than it does for these kind of structures. That's a compelling reason to move over to these. Robots will be more green in the future. The third factor about these things is they're actually able to alter their stress, pre-stress on the fly. This bear has just cranked up his pre-stress, and everything within about 5 miles has also cranked up their pre-stress. So this is called viscoelastic, where you're able to relax a structure, have it be very fluid, and then crank up the tensions and have it be rigid. So we're fluid or rigid, just depending on how much tension we have at the time. That's remarkable. And future robots will be able to do the same thing. So a couple examples of this, see in the world. Viscoelastic things, you can actually run across a pool that has cornstarch in it. If you stop in the middle, you'll sink down. Same way with a Tempur-Pedic bed. If you slap it, it won't do anything, but you let your hand gently rest on it, it'll start to sink in. We love to crank up the stress in our bodies. We just had our national pre-stress holiday, otherwise known as Halloween. All sorts of outdoor activities we love to crank up our stress. Some indoor activities we also like to crank up our stress. The opposite of this is body-mind disciplines. So you can go to a class to do these, or if you're really smart, you'll figure out a way to do them all the time. That's Kathy Sierra at her workstation at home. So, robots of the future will have all of these qualities there. Be remarkably material efficient, remarkably energy efficient. So the question for you, do you act like a 1.0 or a 2.0 robot when you move around? And we have an exercise about that. So pick the word from this that most inspires or intrigues you, and then close your eyes. So what would it be like if your body had that quality, felt like that, right now? Great, thank you very much. Here's your homework. have slide notes available online, really great slide notes available for download. If you take this homework and run with it, if you annihilate the tension as a regular practice in your body, you will have amazing results. Thank you very much.